Hi, have you ever thought of understanding transistors or use them yourself and it feels complicated? Don't worry, I got you covered. Before the end of this video, you should know how to build your own circuit using transistors, where I'm going to take you how to build a light dimmer circuit, and also we are going to be building a magnetic detector, also using a transistor, also a motion detector using an LDR, and we are going to do things like a remote control switching using a photodiode, and also a flame detector. So stay with me. The word transistor came from the word transfer and resistor, a thing that acts like a resistor but one that can be controlled, that can transfer a signals from input to output. Like it's always said, it's a three-terminal device that can amplify and also act as a switch. There are two types of transistor, which are the bipolar, which is known as the BJT, and also the MOSFET. And this is an example of a MOSFET transistor, but I'm not going to be discussing this in this video. What we are going to be focusing is the bipolar transistor, also known as the BJT. The word bipolar there means two polarities, which are the negative and the positive polarities, and this is how a transistor are constructed. And with this, bipolar comes in two types, an NPN and a PNP. This helps us to know, we electronics hobbyists, to understand what type of transistor we are operating with, if it is an NPN or a PNP. We're going to know how to connect this because their connection are just the opposite later in this video. Okay, think of any mechanical switch that you know that requires a person to keep on pushing on and off the switch to control a circuit or to control either a light bulb. And you can also see me doing this repeatedly. But for the transistor, it is different. We are going to be using this BC547 transistor. And from its datasheet, we can tell that it's an NPN transistor. With the flat surface of the transistor facing you, we tell the pinout of the transistor starting from the first lead, which is the collector, the second lead is the base, and the third lead as the emitter. But this doesn't apply for every transistor. Some transistor will have the other way around. So do check for their datasheet using the part number written on any transistor you can find using your web browser like Google or maybe your Wikipedia. Let's say connecting your transistor its first leads and its last leads as you would do in a normal switch. You can see our circuit remains off. Hold on, think of it. How can we turn on and off this light bulb? So here is where the mystery of transistor happens. Here is the hidden secret. Its base. Yes, the base. The base lead is the hidden secret. It's the switching point, and it's used to control the amount of current flow in a circuit. So if we apply a current at the base pin using an external battery, you'll notice the bulb coming on and goes off each time we disconnect the battery. So here is a transistor. I'm using a BC547. Here we have our collector, the base, and the meter. And you can see we have the flat surface facing us. So place your LED such that its cathode faces the collector pin. And next, with the battery, I'm currently using a 9-volt battery, connect its negative polarity to the emitter pin and its positive to the anode of the LED. But this is wrong. You need a resistor to prevent inrush current from destroying the LED. So we want to turn on our LED. We need a 1.5 volt battery. It can be more than this, but it has its limit. And if the voltage is less than 0.6 volts at the base, this won't be enough to turn on the transistor. So make sure that if you're using any battery, that battery should be more than 0.6 volt so that this can trigger the base of the transistor. Don't get confused. I connected the negative contact of the battery holder to the emitter pin of the transistor, and notice each time I make the positive contact with the base, the LED turns on, but not bright enough. This is because current at the base controls any circuit at its collector leads. So the more current at the base pin will determine the amount of current coming into the collector pin. Okay, let's see what happens when we use this 3.7 volt battery. So get its negative polarity connected to the emitter. Mind you, the emitter of any NPN transistor is always connected to ground. So let's see what happens when we take its positive to the base terminal. But wait, doing it this way will cause a huge damage to the transistor, so we need a resistor to limit inrush current into the base from destroying our transistor. And we can see that we have our LED turned on and it's brighter than before, but I'm going to use an LED. It seems this LED isn't that bright for you to see. So I think this is better because now you can see the lights more better than before, because it's already transparent. So let's see how we can do this without using an external battery. Okay, from my schematic you can see that we have a resistor and a push button switch connected to a power supply 9 volts. Anytime the switch is closed, the current too will be shared to the base terminal and turn on our LED. So here is my circuit on breadboard. You can see how I did all the connection on the breadboard. So each time I close the switch, you can see we have our LED turning on, and taking off my finger, the LED goes off. Like I said earlier, the connection for a PNP and an NPN transistor is just the opposite. You can see we have the positive supply coming into the emitter pin, and we have the base going into ground, and then we have the resistor before the LED at the collector pin, and then we have the cathode connected to the ground. So here is a BC557 transistor, and it's a PNP transistor. Always remember to check for the datasheet. So place your LED such that this anode is in contact with the collector pin. But this is wrong. I didn't see the LED first. We need the resistor first before the LED. So we are going to have a 220 ohms resistor, and then next we can now add our LED. So place your push button switch according to the schematic diagram. Connect a resistor to this first lead to the base of the transistor, and then the second lead of the push button switch, place a jumper wire in contact with the cathode of the LED. Remember, this is the ground. Now watch, you will notice that the battery came from my right hand, but before in the NPN it came from my left hand side. So connect the negative polarity of the battery to the cathode of the LED, and the positive polarity of the battery to the emitter pin. So each time we send the base pin to ground by closing the switch, you notice our LED turns on. Alright, let's move into the next project. And here on the schematic we can find that we have a different kind of switch. It is a reed switch, and we have an NPN transistor. Okay, this is a reed switch with two metals inside of it. So we can see that in the reed switch we have two metals that are separated. So each time a magnet is brought close, the switch closes, and which makes current to flow into the base of the transistor. Okay, from the schematic I have everything connected, and if I should bring a magnet close to the switch, you can see it detects it. So let's move into the next project. Okay, here on this circuit we can find a potentiometer which acts as a voltage divider that can be varied. So according to our schematic we have everything in place, and here is the potentiometer, and we can see the first leads connected to the power supply rail, and we have the middle leads connected to the base pin of the transistor, and then the last leads connected to the emitter of the transistor. And watch, each time I vary the potentiometer you can see our light getting brighter each time I increase the value, and you will notice each time I decrease the value of the potentiometer you can see the LED getting dim. So let's move into the next project. So we have a voltage divider circuit again, which varies with light automatically, where the LDR value or resistance decreases with the intensity of light and increases in the absence of light. So each time the resistance drops, the output to the base goes high, and if the resistance increases, the output goes low. Okay guys, we all have our LDR and a 10K resistor connected in series, so we are going to be testing our project. You will notice each time an object blocks the light falling into the LDR, the resistance increases, and this will trigger the base of the transistor high. And each time the object is taken off, the resistance in the LDR decreases. So let's move into the next project. Here on the schematic diagram, we can find that we have a photodiode which detects infrared, and how this is used, it is placed in the reverse direction, and you can see this already in the reverse position on the circuit. Okay, here we have our circuit and we have the photodiode. The flat edge is where you use to know our cathode, and you can see it's connected to the positive side of the battery, and we have the anode in between the resistor and the base of the transistor. So here I have a remote control, so you can use any remote you have at home. What is detecting is just the infrared in the remote control. Please do not forget to hit that subscribe button and keep your notification bell on so that you'll be notified anytime I upload a new video. We can still use this as a flame detector. And please, I would like to know your thoughts about this video. Comment on the comment section below, and links to other videos below the description box.